Okay, this is 5.5. So, Donna must choose a shirt and a pair of pants for today's outfit. She has 3 shirts and 2 pants. How many different outfits can she make? So, one way to do this is to write out all the possibilities. So, let's call the shirts red, green, blue, and we'll call the pants number 1 and pants number 2. So, what is an outfit that she could wear? R1. What's another one? R2. Okay. What about 2R? It's the same thing, right? Put your shirt on first and your pants on second. Is that any different than putting your pants on first and your shirt on second? No. Same thing. Did I say that the same way? I don't know. You get what I meant. Okay. What else could she wear? G1, G2, or B1 and B2. So one question we have to ask is, are those the same thing? Yes. Okay. Sometimes when you're putting things together into pairs or groups, R1 and 1R are exactly the same thing. So if you put your shirt on first and your pants on second, that's exactly the same thing as your pants on first and your shirt on second. So in this case, there are 6 possibilities. Okay. So let's say we have 5 people in a contest. Let's make this easier. And in the contest, we give the first place person $100 and we give the second place person $50. What are the possible ways to do that? So we could give 1 the $100 and 2 the $50. What else could happen? 1 3, 1 4, 1 5, 2 1. Is 12 equal to 21? No. They're different, right? So in this case, order matters. In the last one, order didn't matter. R1 and 1R meant exactly the same thing. But sometimes order does matter. Why is 12 different from 21 in this case? Are you going to care which place? If I just said, okay, one of the winners is person 1 and one of the winners is person 2, and I don't really care which is which. Would you care? Yeah, you want the $100, right? So we could have 2 3, 2 4, and 2 5, and 3 1, 3 2, 3 4, and 3 5. 4 1, 4 2, 4 3, and 4 5, and 5 1, 5 2, 5 3, and 5 4. Okay. If you have similar situations, so if you have 5 things and you're picking a group of 2, order matters will always have more than order doesn't matter. So a lot of these are duplicates. 2 1 is a duplicate, right? 3 1 is a duplicate. 4 1 would be a duplicate if the order didn't matter. Okay. All right, so let's go on to the next question. Factorials. What does 4 factorial mean? It means 4 times every natural number smaller than it. So this would be 4 times 3 times 2 times 1. Okay. And this is asking us to calculate 5 factorial times 2 factorial divided by 6 factorial times 4 factorial. So we write it out. 5 times 4 times 3 times 2 times 1. 2 times 1. 6, 5, 4, 3, 2, 1. And 4, 3, 2, 1. And then we just start crossing things out. So those all get crossed out. And this gets crossed out. I guess you could cross out that too. So what's left in the numerator? On the bottom, yeah. So what's left on top? Nothing. So we put a 1. What's left on bottom? 6 times 4 times 3, which is 6 times 12, which is 72. 1 over 72. Okay. Let's look at another one. All right. So 4, 3, 2, 1, 5, 4, 3, 2, 1. And 2, 1, 7, 6, 5, 4, 3, 2, 1. All right, so we can start with those. Oops. And then this one can kill that one. Anything else? Well, 3 goes into 6 twice. And 2 goes into 4 twice. So on top, I'm left with 2. And on bottom, I'm left with a 7. That's it. So when ordering the kids' lunch at Burger Universe, the customer must choose a size, whether or not to have cheese, a side order, and a type of drink. Here are the possibilities for each choice. They can choose small or large. They can choose cheese or no cheese. They can choose fries, onion rings, fruit cups, cheese sticks, and they can choose an orange, grape, or cherry drink. How many kid lunches are possible? How are we going to do that? Any idea? Do we want to write this out? So we could say small cheese fries with an orange drink, or a small cheese with fries and a grape drink, small cheese with fries and a cherry drink. And then we'd start a new column. Small cheese with onion rings and an orange drink, small cheese, onion rings, and a grape drink, small cheese, onion rings, and a cherry drink. Yeah, I don't want to count all those, right? So how do we figure it out? Yes. How many how many of these are there going to be? How many SCF blanks are there going to be? 3. Why? There are 3 of those. Right? So SC, how many, I don't know that I want to go through all that. So there are 3 possibilities here, and there are 4 possibilities here, and 2 possibilities there, and 2 possibilities there. So the total number of possibilities is 2 times 2 times 4, which is 16 times 3, which is, what is that? 48. Okay, and look at the explanation here. 2 times 2 times 4 times 3 is 48. Okay. All right. Don't want to quite do that one yet. Here we go. Okay. We're gonna stop there. Okay, we're gonna split this into two different days. Yeah, just do those problems for today, and then we'll come back and finish later.